Well, if you've gotten this far on the problem, you've got the rate law expression. You know the rate is equal to a constant, that better be the same, times the concentration of the NO squared, important, times the concentration of the hydrogen. And we're trying to find now the rate constant for this. Now we are going to use trial 1, and in trial 1 you can see we've got the concentrations of the NO and the H2, and we've got the instantaneous rate. So all we've got to do is plug into our equation to see if this thing works. So I've got my calculator ready, and we'll put those numbers in to see if indeed the NO is important and the hydrogen is important. So to solve this, a little bit of math, I'll take my instantaneous rate, which is 5.79. I'll type that in my calculator now, 5.79. Of course, we have to raise that to the times 10 too. In our calculator, that's the E button, and that's a -6 molar per second. And we're going to divide that by the NO concentration squared, which is going to be 0.0027. No need to put that extra 0 in and square it. We've got a squared button. Get that in, and then you got to divide again by the 0.0049. If you put a multiplication sign on it, you have to realize calculators go from left to right, and you'd be multiplying. I mean, you got to divide by this one. Either that or use parentheses. So I'll type in my 0.0049, 0, get that 0 in, 49, and enter. See what our constant is going to be. So let's see what this constant is. Enter. So our rate law is going to be 162. That's a pretty large number per molar squared per second squared. So that's our answer. Now, if this is really correct, no matter what set of concentrations we use, we're going to get the same rate constant. I mean, that's why this equation is supposed to work. So we can figure out rates at any time given any set of concentrations. So let's put this second trial in. You really shouldn't. I mean, it should be the same answer, but if we're compulsive, let's just double check to see if our rate law expression is good. Yeah, and I'm going to take my rate, 0.231, a little bit faster, actually 4 times faster, times 10 to the -5. There we go. Divided by our 0.0054. Our nitrogen monoxide was double, so our rate's going to be 4 times faster. Don't forget to square that. So put the squared in and divide by the hydrogen, which didn't change. So we could use that comparison, 0.0049. And let's see if we get the same answer. This is a real check. Oh, this is tense. There it is. Oh, the same answer. And it always should be. So really, you could put all 3 in. And if you want, you can try the third trial to see if it really does work. But this means that our rate law expression does work. The NO squared times the hydrogen times our 162 will give us our instantaneous rate at those set of concentrations. What a beautiful equation.